Hello, welcome back to the third video on limit fit and tolerance. After fit and its various classification, the next term is allowance. Allowance is defined as an intentional difference between the maximum material limits of matting parts, that means the hole and shaft. For a shaft, the maximum material limit will be its high limit, and for hole it will be its low limit. Let us consider an example of a clearance fit as shown in this picture. Here we will consider the shaft first. So the shaft, the tolerance zone is shown, and the lower limit and the higher limit is shown, that is the maximum limit and minimum limits. So here on inspecting or watching this picture, we can tell that the material, the maximum material in the shaft will be corresponding to its high limit or maximum limit size. Similarly, for a hole, this material, this one is the tolerance zone. So this is the lower limit and this is the high limit or upper limit and lower limit. And the material will be more in this part when it will have a size of equal to lower limit or corresponding to lower limit. So for a shaft, the high limit is the maximum material condition, and for a hole, the lower limit or the minimum size is the condition for maximum material. The allowance may be positive or negative. So the positive allowance is termed as clearance and negative allowance is interference. Or otherwise, for an interference, the allowance will be always negative, and for clearance fits, it will always positive. Let's consider an example of a clearance fit. Here the hole dimensions are given as 28 plus 0.2 and plus 0.3, and the shaft dimensions are given as 28 minus 0.1 and minus 0.2. Then the allowance is given as maximum material limit of hole minus maximum material limit of shaft, that is equal to from this dimensions we know that the maximum material limit of hole is the minimum size of the hole. So here it is 28.08, 28.2, sorry, 28.2 minus, and the maximum material limit of shaft is the maximum size of the shaft. Here the maximum size of the shaft is the 28 minus 0.1, that is 27.9. So the difference is 0.3 mm. So here the allowance is 0.3 mm and that is positive. So this one is result in the clearance. Now another example with an interference fit. The sizes are given like this: 28.00 and plus 0.2 for the hole, and 28 plus 0.3 and plus 0.4 for the shaft. Here the allowance is again, it can be defined as maximum material limit of hole minus maximum material limit of shaft. So that is equal to the maximum material limit of hole is the minimum size, that is the 28.0, and minus then the maximum material limit of shaft will be its maximum size. So it is 28.4. So the difference is minus 0.4 mm. So this is the allowance. Since it is minus, so this will result into an interference fit. In this picture we can show the allowance as this one, that is, this is corresponding to the minimum size of the hole and this is corresponding to the maximum size of the shaft, and this distance is actually the allowance. Finally, we consider an example of a transition fit. Here the sizes of hole and shaft is given as above in this picture, and the allowance is the maximum material limit of hole, that is its minimum size. So again this is 28.0 minus maximum material limit of a shaft is its maximum size. In this picture, we can see that it is 28.1. So the difference is minus 0.1. Again, it is minus. So the allowance for this transition fit is an interference. That is, this allowance actually leads to interference, and it can be shown this picture because this is the minimum size and this is the maximum size. This is the maximum size of shaft and this is the minimum size of the hole. So this distance is actually representing the allowance. For getting a particular fit, we need to change the size of hole and shaft. But if we change both, it may be complicated. In order to simplify the process, we either fix hole size or shaft size and vary the other to get the different fits. If we fix the hole, then it is known as hole basis system. And otherwise, if we fix the shaft size and we are varying the size of hole, then it is known as shaft based system. Hole basis system is expressed with a hole with a capital H. This capital H is indicating that hole, and this capital H is the fundamental deviation of the selected hole. And on the other hand, for shaft basis system, we are using a basic shaft which is represented with a small h, and this small h is the fundamental deviation of the selected hole. In a hole basis system, we are fixing the hole size and the shaft sizes are varying to get different fits. Just like if the shaft size is less than the selected hole, it is clearance. If it is more than the selected, more than the shaft size is more than the hole size, then it is interference. And if the tolerance zones are overlapping like this, then it is transition. Similarly, in shaft basis system, the size of the shaft is kept constant and we are varying the size of the holes. Here the hole is larger, so it leads to clearance. Here it is smaller, then it leads to interference, and in transition the tolerance zones are overlapping, and as in this picture. Since we have got two systems, that is hole basis system and shaft basis system, then a question arose that which one is mostly used. So the answer is hole basis systems, and the reason is that the hole making tools are standardized. We know that the tools used for making holes start with a drill. So drills, you know that these are standardized. The size of the drills are standardized. Then it is again finished with the hole is drilled hole is finished with another tool known as a reamer. A reamer is also available in standard size. Then internal thread is made with tabs, that is also standard size in standards. So all the hole making devices are available in standard size. So hole basis system will be better because we have to stick on a particular size of a hole, and the shaft is an external feature, so its size can be varied easily compared to varying the size of a hole. That's why the hole basis system is more popular compared to the shaft based system. In the next video, we discuss about fundamental deviations and grades of